Right. I want us to check how we set these problems in the exam situation. We're using the paper for November 2008 as an example. We'll also take the 2008 in the old paper 3 because it has come back to paper 2 from 2015, in fact from 2014 onwards. Looking at this example, it was question 9 in that particular exam. The time taken in minutes to complete a 5-kilometer race by a group of 10 runners, so we're given the number of them, there are 10, is 18 minutes, 21 minutes, 16 minutes. This is just the data that has been given. It has not been organized. It's just the data. What are the questions? The first question, calculate the mean time taken to complete the race. I usually say it is advisable to read all the questions before answering them because it will help us to know whether we're going to need this value to use on the other one. Calculate the mean time taken to complete this particular race. What is the mean? When we're doing our definitions, we defined what a mean is. It is nothing else but the average. It is the average. So how do we find the average? We add all these times divided by the number of them. This is the sum, remember, the mean. It is x bar. This is the symbol for the mean. The mean is the average. It is equals to the sum, let me just do it right, the sum of all the observations divided by the number of observations. So that formula becomes vital. It is the sum of all of them divided by the number of them. So all that you need to do is simple. That is why it is usually between 2 and 3 marks in your exams. You punch your calculator, you add all these numbers, then you divide it by the number of them. You are told that there are 10. You can confirm that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You punch all those 10 observations into your calculator, sum of all of them, then you divide it by the number of them. That will be called the x bar or your mean, which is the average. But I'll prefer that you just take your scientific calculator, put them onto the stats mode so that you'll be able to use this data. All that you need to do is to go to your calculator, go to mode button. In the mode button, you'll see number 1 is comp, number 2 is complex, number 3 is stats. That's where you go. Whatever calculator that you're using, you check where there are written statistics there. It's usually STAT, which stands for statistics. You punch that button. In this particular calculator that I'm using, the FX99IES Plus, it is number 3. So I punch 3 for stats there. What is it that I want to do? I want to calculate my mean. But the only thing that is going to take me into my mean is my number 1, which is the variance, number 1. I go to button number 1, so you look for the button for VAR, which stands for variance. You go and push that button. In this particular calculator, it is number 1. I punch that one. It gives me my bars on which to work on. So on those columns, all that I need to do is to punch those observations that I see there. The first one is 18. I say 18. Then I press equal sign to enter it into my bar. The next one is 21. It's 21, 21, you enter. You do that until we enter all those. Make sure that there are 10. And the guide next to it, there are numbers. One, as you punch it, 1 shows, 2 shows. It must show up to 10, all of 10 digits so that you can see that you've entered all of them. Remember, so far you've just entered 2, 18, and 21. The next one to enter is 16, 16, enter. The next one is 24, 24, enter. The next one is 28, enter. The next one is 20, 20, enter. The next one is 22, 22, then you enter it. The next one is 29, it's 29, enter. The next one is 19, enter. And the last one is 23, 23, you enter. Right, you must make sure that your calculator shows that there are 10 digits that has been entered there. It must show that there are 10 digits that are entered there because make sure that you enter them all. Once you've got all your digits entered, then you press the AC button. The AC button, you press the AC button. Once you've entered your AC button, after pressing your AC button, then you go to shift mode. With this particular calculator, it is up there on the top left-hand corner, the shift mode. You press your shift mode. After pressing your shift mode, what is it that I'm doing now? I want to go to stat mode, which is under 1 in this particular calculator. It is under 1. That's why I was pressing shift there first. Then I press my 1. Then I've got about 6 readings there. The first one is type. Number 2 is data. Number 3 is sum, and so on and so forth. Remember, I pressed the first one that I pressed before, which was variance in this particular case. It is number 4 in this particular case. Number 4. I go and press number 4. I press my number 4. What is it that I'm looking for? Remember, the calculator's got everything that I want now. What is that I'm looking for in this particular case? I'm looking for X bar. X bar. Do I see X bar there? Yes, I see X bar. What number is X bar? It is number 2. My X bar in this particular case is number 2. All that I need to do is to punch number 2 and I'll get the solution. So my X bar in this calculator is number 2, then equal sign. Yes, I get a value of 22. So the time taken, calculate the mean time taken. The mean time taken to complete the race, the average time there was 22 minutes. So we know that X bar in this particular case, it is where I add these values. In this particular case, I have added 18 plus 21 plus up to the last one, which was 23. I divided by the number of them. In this particular case, how many of them are they? There are 10, divided by 10. I don't have to show all of them because I've punched there in my calculator. Then my X bar, remember, it's only 2 marks. It's 1 mark and 1 mark for the solution. This then is equals to 22 minutes. So that's how I calculate the mean time taken to complete the race. So on average, these 10 runners took about 22 minutes to finish this particular race. Let's move on to the next question there, question number 2. Once you put your X bar, don't take it out of your calculator. Leave it there. All that you need to do in your calculator is just to press AC. Now, pressing AC, it means that I still have the data that I've been putting there. So it's still saved in my calculator, hence I'll be using it. Let's move on. Calculate the next one, 9.2. Calculate the standard deviation of the time taken to complete the race. Remember, when they ask you about the standard deviation, you go back to your data sheet, it gives you the formula. This is the formula to calculate the standard deviation. If it is squared here, then there is no square root sign. If it is squared, right. That is the time taken to, what is the time taken to complete the race? Or if I want to do that, I'm going to use my calculator to make my life easier. My standard deviation will then be equals to, okay. Do I know my X bar? Yes, I know my X bar. You push in all these values. The first one, you push in the second one, you push in the third one, until you put all of them there. They are all squared. You divide it by the number of them, in this particular case, which is 10. Now, how do I do that? Using a calculator. It's very easy. All that I do is just put a few values there, the sum of all 10 of them. The first one is what? It's 18. It's 18 minus the standard deviation. What is my standard deviation in this case? It is 22. It is 22. I add another one, the second one, which is what? Which is 21. Or if I've added the first one, I indicate that there are some that I've skipped. I've gone to the last one to make life easier for me, which is 23 minus the standard deviation, 22 in this particular case, and divided by the number of them. So there are some that I've not written there because of time. You don't have to show them. You've got to show as I'm showing you. Then my standard deviation will be. All right, what do? I go back to my calculator. Remember, I already punched those values. I don't have to redo them again. All that I need to do, I go to Shift Stats. I see all those buttons again. How many observations I see? There are about 6 of them. 6. Which one am I looking for? The variance. Number 4. I go and punch number 4 in my calculator. What do I see? Do I see any button that has the standard deviation there? Yes, I can see that button. In this particular case, it is button number 3. Once I punch number 3, it will take me exactly to my solution. I punch number 3. I got the solution. The solution is 3,95. So it is 3,9496. So it's going to be 3,95 5 minutes. So this is what we call the standard deviation of these runners. Remember, they deviate away from the mean, standard deviation. Right, the last one. This one usually comes out more often in our exams. It says how many runners completed the race within one standard deviation. What do you mean by that? Let me just do it to this side first. If I have something, let me just take this out because I've got it. If I have, normally, if this is what we call a normal distributive curve. This is the negative part. If this is my mean, just do it in dotted lines. If this is my mean, we are saying there'll be more people in a class, or maybe in a classroom situation, there'll be more people that will be belonging in this part. More people that you'll be finding here, a bit lesser people there, a bit lesser this side, and you'll find less people that are outliers. In other words, for example, in any observation that I'm doing, in a classroom situation, you'll find a number of learners that will be getting around 40, 50, 40, 50, 60. But those that are getting 70s or 70s, they're a bit smaller than the ones. The ones that are getting 80s are very, very small. The ones that are getting zeros on the other side are on the negative side are very, very small. So we are saying in a normal situation, 34% will be towards the negative part of the standard deviation, which is 34%. Another 34% will also be going towards that side, towards the positive side. And 14% will be a bit clever, and only 2% are brilliant. So this side, on the positive side, is the same thing happening on the negative side. 14% are very bad, and only 2% are hopeless. So this becomes normal. If you add all of them, it will give you 100%. So there are more people that belong into this sector here. From here to here, we say it's on the positive side. We're moving we are deviating once here. From here to there, we're deviating twice. So from here to here, you say this is within one standard deviation towards the positive. And from this side to this side, it's also one standard deviation towards the negative. It's only one SD. From here to there, it's 2 SD, 2 standard deviation. From here to there, from here to here, it is also 2 SD towards the negative. So when we talk about the position where it is within one standard deviation, it is this position, where we deviate from the mean once this side and also once this side. So that is what we call within one standard deviation. So the question is asking about that. This question says, how many runners completed the race within one standard deviation? We want the number of these runners that completed the race within this region. Remember, when you check the percentage of them, it should be around 60%, because there will be more that will finish within one standard deviation than those that will finish within 2 or more than 2. Right, let's check this one out. How many runners completed the race within one standard deviation? So we use the formula that says, for one standard deviation, they should be within this range. They should be within this range. So how do you get that? We say we want the runners that will be within this range. We said it is the standard deviation as x bar minus, if it is that side, remember that there will be 2. It is x bar plus, if I'm going that side, plus standard deviation. So it is x bar plus standard deviation. From here, it's x bar minus standard deviation minus SD. Right, this is the formula that we use. Remember, you don't also get it in your diagram sheet, so make sure that you understand it. It comes from this information. This is one standard deviation, one standard deviation. From here, we add. From here, we subtract. Just like you move in your number line. Do I know my x bar in this particular case? What is my x bar? My x bar was 22. We've calculated in the first question. It was 22. Do I know my standard deviation? Yes, it is 3,95. So I go and put them in here. What is my x bar in this particular case? It is 22 minutes. 22 minus the standard deviation, which is 3,95 minus 3,95 is 2. Standard deviation again, x bar, which is 22, plus x bar, in fact, minus plus standard deviation, which is 3,95. 3,95. This then will be, right, let's work this thing out. What is this going to be? Let's quickly work it out. We've got 22. It's minus, again, do it off by heart, 3,95. Yes, it is equals to 18,05. This is 18,05 is 2. 22, you just add that, you just go to your calculator if you like. Instead of minus, you delete it, you plus plus, it will give you 25,95. It is 25,95. Now, what is this saying to us? It is saying that runners, I think I need my data again. It is saying runners that will fall within 1 standard deviation are runners who made this time. Remember our data. Let's remember, quickly recall on our data quickly. Remember that we had about 10 runners. Let me quickly write them here. The first runner got, it's 18. We had 18. Oops. We have got 18, 21. We've got 16, 24, 28, 20, 22, 29, the other one made 29 minutes, 19, and 23. These are the times that were made by these runners. Now the question is saying, how many runners completed the race within 1 standard deviation? Now this is telling us that those that completed within 1 standard deviation made this time between 18,05 up to 25,95. Those are the runners. Now let's just check how many runners that falls within that range, within 1 standard deviation. If we check 18, is 18 between 18,5 and 25,9? No, it is not. So this one is not part of my solution. 21, is 29 between 18,5 and 25? Yes, it is. So this is number 1. Is 16 within that range, between 18 and 25? No. Is 24 within that range? Yes, it is. Is 28 within that range? No, it is above 25. So this one is not. Is 20 within that range? Yes, it is within that range. Is 22 between 18 and 25? Yes. Is 29 between that? No. 19, 18, yes, 19 is. Is 23 there? Yes. You just check the number of runners that completed the race within 1 standard deviation. Let's check them. It is 1, 2, 3, 4, 5, 6. Yes. Therefore, 6 runners completed the race within 1 standard. Therefore, 6 runners completed the race within 1 standard deviation. This is how you solve this in your examination situation. Thank you.